Hello guys, welcome back to another lecture in this course. In this lesson, which I'll be focusing on linear transformation. So a linear transformation is a function or a map. For example, we can say a function which is f for function and is mapped to v. So we have u, which is a vector, which is mapped into another vector v. So if you are having at least a function, for example, which is having, let's say, u1 plus u2. If you are mapping this function, it will be equals to a function of u1 plus a function of u2. And remember, this is for all vectors, including the function. And if we are to include a scalar, we are saying our function of alpha, where alpha is the scalar, u, is equals to our scalar, which is alpha, function u. Here, this is for all scalar values in the vector u, v. And in linear transformation here, we are saying, for example, we are having t. So let's represent t as transformation. We are representing t as transformation. So in linear transformation here, we are saying given values in the coordinates, we are having x-axis, we are having x value and y components in a vector space. And this transformation can be mapped to 2x and 3y. Or we can say it can be mapped to minus 3y. It depends. So we are saying here the linear transformation, which is t, and it takes in two-dimensional vectors, which is x and y, as input. So these are our input. And it is mapped or it is processed. It is processed, then form another two-dimensional vector. This two-dimensional vector as output. So to understand the properties of this linear transformation, we can try to say we are having transformation which is taking input 1 and 0, and it is mapped to another two-dimensional vector 2 and 0. So we are just saying this result that we get here, just indicating that in the x-axis, unit vector, which is 1 and 0, is transformed to vector 2 and 0 under a linear transformation, which is t. And this same goes also if we are to do a transformation in the y-axis. And remember, when we do a transformation in the y-axis, it means x is equals to 0. So we are saying 0 and 1. And it gives us minus 3 here. So the result, this result, as we can see here, it indicates that the y-axis or the y-axis unit vector, which is 0 and 1, is transformed to the vector 0 minus 3 under a transformation t. So in transformation, we have a lot of things. This is just a brief overview. Now in transformation, we have 4 elements. We have 4 aspects that we can talk about in transformation. In these aspects, we have reflection. We have reflection in transformation. We have the translation. We have translation. We have rotation. And finally, we have the enlargement. So we have enlargement, rotation, translation, and reflection. And enlargement is where we have to either enlarge or shrink. These are main aspects. They happen within transformation. And when we say reflection, when we talk about the reflection, we are assuming, for example, you are having a mirror, okay, and you are looking into a mirror to see yourself inside the mirror. So you are reflecting yourself inside a mirror. So, for example, here, let us take a look into a Cartesian plane or a vector space where we are having y-axis here, and also we are having x-axis. Assuming this line is our mirror line. And we are having a vector point, let us call it point A. And we want to reflect using this as a mirror line. It means if this point up to here is 2 centimeter with the length, it means that from this mirror line up to this point also, we'll have another point P here. And we put 1 on top, power 1, to indicate this is a new image of point P. And the distance should always remain the same. So if same applies if we are reflecting in the y-axis. So we reflect in the x-axis, for example, point P here, and we want to reflect this point P in the y-axis. It means it goes also on the same point here. So this will be used as a mirror line. It reflects with the same distance. Here, when we reflect in the y-axis, it means x is equals to 0. When we reflect in the x-axis here, it means y is equals to 0. And there are some times when we are reflecting where y is equals to x. And it happened at this point here. This is y, this is x. So here, this line here is y equals to x. And when we say y is equals to x, we are saying given coordinates, for example, let us say we are having a reflection in the line y equals to x. And we are having 1 and 0. It means when we are reflecting in the y equals to x, we are just saying x, y value. So if y is equals to x, then it means x is equals to y. Therefore, the value will be y, x here. So, and obviously, in this case here, we are just saying this will be 0, this will be 1. So if we are moving, it means, for example, this is 1, this is 0, then it means the other value is going to come here, where here we are having 0 on x and 1 here. So this will be the reflection in the y equals to x. And also if you are to add even a negative sign, it means it will be a negative in this line here. This will be y equals to minus x on this line here. So we can talk about a lot of things in the reflection in the y-axis, in the x-axis, in y equals to x or y equals to minus x. Let us take a look also a brief overview in rotation. So rotation here, we are saying rotation is a transformation which rotates all points on a plane about a fixed point. For example, in rotation, we are saying we should have what we call a center of origin. For example, we have a straight line here. We have a straight line, and this is the center of origin. And we have a point here, which is B. And we want to rotate this at 180 degrees. So it means if you have to take your compass and you put it here and you do 180 degrees, it means it will move on this side. So it means B will be here. So this is 180 degree rotation. And same applies if you are to rotate B at a 90 degree rotation. It means 90 degrees, it has to bisect at the center. So 90 degree will go up to here. B will be here also. Same applies up to 270, up to 260. So if a given point, let's say y-axis, x-axis, and you are given P here, and we're asking you to rotate at a 90 degree angle, it means this one is 45. So at a 90 degree angle, anti-clockwise direction, it means it will come here. So when we say anti-clockwise, we are going this way. When we say clockwise direction, it means we are going this way. So this is clockwise, this is anti-clockwise, we are going this way. So it means if you are rotating, this will be our P1. If you are rotating this P at a clockwise direction of 90 degrees, it means we are going this point, then P2. So here 45, here another 45 to form 90 degrees. So this is a brief overview of rotation. And the rotation, what you need to know is you have to know three things: center of rotation, the center of rotation, and also you need to know the direction the direction of rotation, and also you should know the degree of rotation. Degree of rotation. Once you know, are you rotating at a 30 degree, a 20 degree, and on which direction? Once you know this aspect, rotation is simple to deal with. Now let us take a look also into translation. So translation is another form of transformation, but this is just the movement of the object on a vector space, either downward or upward, left side or right side. For example, let us take a transformation with the components -2, -5. We need to translate it. We need to translate with let's say to translate with 2 and -3. So to translate this on a vector space, we are just saying we need this transformation 2 -5 to be mapped here into x1 plus x2. These are our first coordinates, y1 plus y2. So this will be our x1, this will be our y1, this will be our x2, this will be our y1. So we are just adding these according to the coordinates. So it will be mapped to -2 plus 2 and -5 plus -3. And this will give us 0 and -8 here. So if you are to represent this on a Cartesian plane or on a vector space, we are simply saying x it's -2. Let's say -2 here, y it's -5. Y is -5. So the points are meeting here. This is point, let's say point A. We are translating this point 2 on the x-axis, 2 steps on the x-axis. So here we are saying 1, 2 on the x-axis to the right side. So we go here. Then -3 on the y-axis. So -3. So after moving this to this point at 5. So now we need to move -3 steps. So we are saying here 1, 2, 3. So it means we are going to come at this point. From this point, after moving -2, +2 on this side x-axis, so this is x, this is y, this is the positive side of x, this is the negative side of x. This is the positive side of y, this is the negative side of y. So we are moving, after moving 2 steps to the positive side of x, now we need to move 3 steps to the negative side of y. So from this point, we move 1, 2, 3. So we end up having a t at this point, t1. So this is called translation. So it means if you are to write in a translation way, we are saying this mark, it takes t -2 -5 we are saying translation is taken to 0 and -8. So the translation or the transformation of -2 through translation is taken to this point, as I have illustrated in this graph. So let us take a look also into another example, considering a linear transformation. Let's say a linear transformation in a three-dimensional vector, which is going to be mapped, let's say, into a two-dimensional vector. And remember where t is denoted by, let's say it is denoted by the matrix M. So we are going to denote this T by this matrix M. So what we can do now, let's say we have matrix M, which is representing our linear transformation, and we are going to put 1, 0, minus 1, 0, minus 3, and 4. Or if we are in Python, we are saying M is equals to square bracket, 1, 0, 1, our list, then another array, 0, minus 3, and 4, another array, then we close our square bracket. This is how we can represent it in Python. Now, to have a clear understanding of a linear transformation, we can apply it into an input. Let's say x is equals to, then our array 1, and we have our second array, and we can have our third array, and this can goes on and on up to xn. And remember that this will be in a three-dimensional space. Okay, this will be in a three-dimensional space. The transformation output vector is y is equals to t of x, in which it is only obtained by multiplying the input vector x here with the transformation matrix that we are having. So here we are just saying that since y here is equals to t x, we are just saying y is equals to t. We say they represent our m here, so it's m times x. Let us assume that x here, let us consider x is equals to 1, 2, and 3. Right. So if x is equals to 1, 2, and 3, this can be represented in a column way. 1, 2, and 3 in a column format. Now, what I want us to do now, we can solve this. Let us say our m is equals to, let us say our new matrix. Let us put the power 1 as our new matrix, or our new vector, 1, 0, minus 1, 0, minus 3 and 4, minus 3 and 4, times x, where x, I said it's our vector here. Let's say 1, 2, and 3. So in our transformation now, we are multiplying using row by column. So if you are multiplying using row by column, we are saying 1 dot 1 plus 0 dot 2 plus negative 1 dot 3. Negative 1 dot 3. Row by column. So we are saying 0 dot 1 plus negative 3 dot 2 plus 4 dot 3, and which gives us a sum of 1 plus minus 3, which gives us minus 2. Here it's 0 minus 6 plus 12. Minus 6 plus 12, which gives us 6 here. Let us dive into Python and see what more we can learn with vectors. For example, with me here, I have a linear transformation matrix that I'm having here that we have been using in our example. We are using minus 1, 0, minus 1, as you can see. So we are just using the same example, the same input here, and I've created an array. So what we need to do, we have to define our input, and our input is x, which is 1, 2, and 3. Now we are performing the linear transformation. So if I run our code here, we can say that our input, which is x, and this input, after performing a linear transformation, we get a solution which is minus 2 and 6. So this is our output for our y, our value. So another thing that we can do is rotation. So we can do rotation, we can do reflection, we can do translation, we can enlarge, we can shrink, we can do a lot of things with the transformation, which we are going to discover more in machine learning when we do image processing. So here with me, I have an image that I just want to import and rotate using Python. So what I did, I have to employ import the rotate function here from the transformation module that you can see here in ski image, and also matplotlib.py. Matplotlib, it helps us to visualize data in Python. And also I've loaded my image, which is on my download file. After loading my image, I use this path to my desktop, so you can do also the same. Just copy the path and you paste it here. And also our image, I want to rotate it at a 90-degree angle, the rotation point 90-degree angle. And also I want two plots, the original plots of our original image, okay? And also I need another plot for the rotation or the rotated image that you are seeing here. So if I were to run this, let us run here. So you can see that after a rotation, this is our original image here. Then after rotation in 90-degree, this is what it looks like on 90-degree rotation. And also we can rotate in a 45-degree angle. For example, if you are to change here, and let's say 45-degree angle rotation, then we can run our line of code here. You can see that this is the angle rotation. We can enlarge, we can shrink, we can do a lot of things with the transformation. So sometimes you can discover that the input, sometimes they can be the output, and the output, sometimes they can be the input. Depend with how you want to manipulate your data. I think this is all for this lesson. I'll see you on the next lesson, where we are going to dig deeper also more in vectors, where we shall be looking into eigenvectors and eigenvalues. Thank you for watching. Bye-bye.